Good morning, everybody. Okay, today I'm going to work on some problems with form lead code. Let me see here. The problem of 1007 minimum domino rotation for equal rows. So let's get read the problems together. Okay, in the rows of dominoes, top and bottom, represent the top of bottom half of its dominoes. A domino is a house with two numbers from 1 to 6. One of each half of the house. We may rotate its dominoes, that top and bottom, by swapping value, and then we're going to return the numbers of rotation, so that's all the value at the top are the same, or the value in the bottom are the same. So it means if let's say, so if cannot find or cannot done, we return -1. So let's work on the input and output. The output, the inputs of this problem is gonna be number of arrays, two arrays, data structure, so of the top and the bottoms. So and then what they have here, they need to be the same length, so that's why we can compare both of them, right? And then when we rotate, either top or bottom have all the same values, so that's what we can return if they can find out, and then if they can rotate, so we find the minimums of the rotate and then return it the numbers, right? So the output will be numbers. Okay, so in this example, they have tops of number 2, 1, 2, 4, 2, and 2. If we compare with the bottom is the same position, right? So the bottom will be 5, 2, 6, 2, 3, and 2. So in this case, the output will be minimum of 2. Okay, so because of first, when we figure out represent the dominoes as given by top and bottoms, before we do any rotation, if we rotate the second and fourth dominoes, we can make every value on the top rows either be the same to number 2, and then that's what we return second as figures. Okay, and the other one example, like if we cannot rotate and then they cannot find the same numbers, either top or bottom, that's what we return, is just subtract 1. And then what they give us a hint. Okay, they said like a top length will greater than 2, or I mean, not the top length will always like have a length, so at least one element. So that's what a hint means. The inputs will always never be empty. So let's think about the approach in this solution. So it means we want to compare both top and bottom, and then we can try to find how to say, like, more possible when we rotate them, and then we get the result. Come to, okay, what are the other insight to test case, like, so at least if we have one length, and then if we compare them and then they're not the same, and then they cannot rotate, right? So that's what we just return 1, and then it's always gonna have length. So and then I think that's what our test case. And then the time complexity on this problem, I believe if I'm gonna do, it's gonna be O of 1. O of n is linear terms, because linear terms of the length of top and bottom. So it means we need to iterate to every element on the top and compare with the bottom. So it means that's going to be linear terms. And then for space complexity, I believe we don't really store anything, but we're going to have variables to compare, and then the checks. I think the terms, the space will be of 1. So okay, so what is I already write the solution here. What I'm going to do my approach. First, I'm going to have like a variables to hold the values of mean rotation. So that's what we want to reassign later. We find which one is greater of the length, right? And then this solution will be used to keep track of minimum rotation required to make all values at the same. Okay, and then we're going to iterate through each possible value from 1 to 6 because the domino is have value only 1 to 6. So that's we know we're gonna iterate through 1 to 6. So the number will be 6. Okay. Okay, for each value, when we rotate them, when we iterate through the element in the top and bottom, and then if they are similarly, like if they are the same numbers, that's what we're gonna do. We're gonna check if the value is equal. What we do, we're gonna corresponding element to all the arrays. Okay, if the corresponding element in the other array is also not equal, what we do, we want to mean they're not possible to make all value at the same rotation. So if so, we want to just take out of the loop. And then if that's it, we want to increment them, and then we find out at the end if we not find any values at the same and not the same length of the input. I'm gonna use the top length at last, and then we just return subtract 1. That's my approach. So I already write it down here what we're going to do. As we say, we have to have create top count. Okay, that's what we're gonna see. Like I'm going to use array, and then we're gonna have 7 length because value 0 to 6 will have length of 7, and then fill as 0. We fill as 0 because we want to reassign them later, but we want to have 7 length. Okay, and then also have to have bottom count. Okay, and then as I say, we need to have a variable 1 to hold them, and then we want to check if they are the same number. Okay, is same we can set to 0, and then we have to have we need to iterate through the input. Okay, so let me just, I'm gonna say n is set to top length. So n top length, I just use the top. Okay. Okay, so then we need to iterate to one of array using for length I is set to 0, I is less than top length, or n, this I already declare, and increment I by 1, and then we need to fill the values by increment the top count and bottom count by adding the top element to the top count and bottom count. So what I do here, I'm gonna say top count at tops at I, and then we need to increment them by 1. Also do the same thing with the button, but the button we call it button count at the bottom, bottom increment by 1, and then what we do, we have to check if top at I equal to bottom at I is mean if they are equal, if the, like when we increment to top and bottom, right, and then if they are the same elements, what we do, we want to increment is same. Okay, so we now have is same is increment if they make something equal. So we need to have another loop with still O of n because we use only one loop first to find is same, and then we count top and bottom, right? So the other loop, what we do, we want to find is possible when we rotation. So what I'm gonna say, I'm gonna set I is set to 1 because that's what we want to get the value, and then we want to iterate to 1 to 6, right? And then I less than or equal to 6, and then we're gonna increment I as 1. This is what we want to get the value. Is like to rotate, right? And then we want to check here if count top counts. Okay, top count at I, which we already reassigned there, and adding with bottom count at I. and then we want to subtract either same, right? Is same. Okay, so we add top count element and bottom count element, and then we subtract is same if they're equal to top that length, or I think I give like n. Okay, and if they are, what we want to find, we want to return the how many we can rotate. That's minimum. So what I'm gonna do, we just return here inside loop. It means in this loop we not in this case, if we not really iterate through element, if we find some condition, they're gonna stop loop. So that's what is the best way. Okay. What I say here, I'm gonna say n subtract. Oh, yeah, subtract, and then we find minimum, max. Okay, we find maximum, max, and then we compare top count element with bottom count element. That's what we say. What is the max one? If there are some things are the max, and then we return that, and then if we cannot find anything, we just return -1. So that's it, my solution here. So let's run to see if my code is working. Clearing and then run. Okay, that's return 2 and subtract 1. That's correct. And so where is the other coming from? Oh, okay, so let me just comment here. Okay, that's working. So let me run again. That's cool. Okay, that is working. So that's it. I gonna continue working on this problem again and again, like until I just get used to and understand the similar problems. So the issue, I think, we need to practice again and again because some problems cannot memorize. So I did like make a video yesterday about how do I can study and then getting better. So some of my friends give me advice like it takes time, you know. So one guy give me like, okay, maybe when you see a problem and then try to work on yourself maybe 5 minutes, and then later on after 5 minutes, if you cannot find what's in my hair, if you cannot figure out, maybe you go to see the solution and then spend like 15 minutes to understand the solution and then work on yourself. After that, you maybe like 1 hour, 2 hours, 4 hours after, come back to do the same problem again. That's what you're gonna train your brain to memorize at first, and then later on it's like gonna be automatic, and then that's it. I mean, no way shortcut to do anything, even learn English as well. So just need to practice. Maybe not perfect today, but will be later. So, okay, thank you for watching. I will see you next video. Bye.